Hey guys, hope you're all doing well. I've actually got a real treat for you today. Today, we're going to be talking about maths. Jan12, question 6, AQA FP2. I think that's everything I need to say. Let's get on with it. Hopefully this will be better than my last video. Last video didn't go too well. I wasn't able to get to the end of one of the questions. Got some quite mixed feedback from that. One person actually emailed me saying, you need to sort yourself out. And that person hadn't even seen the video, so it was quite tough to take, that was. Yeah, hopefully this one will be a bit better. If you do have any solutions to the question I can do, please, like I said, let me know. That was, just go to my videos, and it was the one before this one. I can't, it was, actually no, it was this paper. It was Jan 12, question 8, part B or part C? Part C. Yeah, the end of part C on question 8, this paper, Jan 12. So yeah, if you can get a solution to that, pop it in the comment for that video. I'll appreciate that. Anyway, moving on. This question is about integration by substitution. They don't tell you what you need to substitute in, so how do we know? Well, let's have a crack at it. 6a. We've got to complete the square on 7 plus 4x minus 2x squared. Now, whenever I complete the square, I always want just one x squared and just a positive x squared, because I know what I'm doing then. I just half the value of x. So this minus 2 in front of the x squared, well, I really don't like that. That annoys me actually quite a bit. So what we're going to do is we're going to factorise out this minus 2 just to leave us with the single x squared. I'm also going to factorise it out of the x term because that's going to go inside our square. We're going to use that to complete the square. Don't need to factor it out of the number term because the number term isn't really anything to do with completing the square. We can have a look at that later. So factorising this minus 2 out, that gives me minus 2 lots of x squared minus 2x. And like I say, we've still got that plus 7. So now I'm happy I can complete the square on this bracket here. I've got x squared, perfect. And I can just half the value of this. So I'll do that. So that's minus 2 times x minus 1 all squared. So x minus 1 all squared gives me x squared minus 2x, but then I've got to think about the number and sort of undo the number I've introduced here. So what number have I introduced? Minus 1 squared is plus 1 multiplied by minus 2. So I've got a minus 2 that I need to get rid of. How do I get rid of it? I add 2. I do the opposite. So plus 2, and I've still got that plus 7. 7 plus 2 is 9, so that's 9. Take away 2 lots of x minus 1 squared for 2 marks. There you go. Not too bad. So whenever you're completing the square, factorise out your x squared and your x term. So you're just left with a single x squared, and then you can pop that into your square brackets. Lovely. Right, let's have a look at the integration part of the question. I need to remember this answer for later, but I've written it down, so I can just look at my sheet. So we need to integrate between the limits 5 over 2 and 1 of 1 over the square root of what we factorised and what we completed the square on in the first question. Cool. Now, whenever we're integrating, especially with a quadratic in a denominator and a square root involved, go to your formula booklet because there's lots of standard integrals for these. So what we're looking for in our formula booklet, we've got this minus x squared here. So we want the integral of a 1 over a square root that has a minus x squared in it. And there's only one of those in your formula booklet. I'm just going to it now. Where is it? I didn't leave the tab open. I closed the tab after I got the formula when I did the question myself a few minutes ago. So AQA Maths Formula Booklet into Google should get it to me. Yeah. Cool. Again, not the slickest of videos, but hopefully I'm going to be able to get the question right. So, yeah, okay. And we can see that the integral, and I'm going to write this down. I'm going to write this down on the side of my page, so I don't have to keep looking at the formula booklet, and I know what I'm aiming for as well. I'm aiming for the integral of 1 over the square root of a squared minus x squared. And the integral of that is the inverse sine of x over a. So I picked out the rule that had a square root and a minus x squared in the denominator because that looks the most like this. Next, we're going to use our completing the square then from the first part of the question. So this is equal to, now, alright, whenever we do integration by substitution, always remember your limits are in the original variable. So these are x limits here. This is between x equals 5 over 2 and x equals 1. And so I remember that. I don't forget it when I swap from x's to u's. What I'm going to do in my limits, I'm going to write as x is equal to 5 over 2 and x is equal to 1. That tip comes all the way from my old maths A-level teacher called Dr. Nagel. Anyway. Cool, so let's compute the square on the denominator. So that's 1 over the square root of, what was it? 9 minus 2 lots of x minus 1 squared. Cool. So to get a minus x squared here, or to get minus a variable squared, we're going to substitute, so it's not going to be x. We don't want this bracket to be x minus 1. We want it to just be our variable. So we're going to make that substitution. We're going to say that u is equal to x minus 1. That means we're going to get a u squared here, which means we're going to be able to use this rule. Now, it will be 2u squared, but we can factorise that 2 out in a second, so that should be fine. And in fact, I'm going to make my substitution now. When we substitute, we multiply this dx by du on du. I can do that because du on du is just 1, multiplying by 1 doesn't change things. And then we shift the denominator along, so it becomes dx du multiplied by du. So I need to work out what dx du is. U is equal to x minus 1, so du dx is equal to 1, dx du is also equal to 1. So I'm going to substitute now, remembering to change my limits from x limits to u limits. And to go from x to u, you just take away 1. So 5 over 2, take away 2 over 2, gives us the u limit of 3 over 2. 1 take away 1 gives us the new limit there of u equals 0. So we've got 1 over the square root of 9 take away 2u squared du. That's looking so much better now, isn't it? Like I said, we need to factorise this 2 out of the square root. That's going to give us a square root of 2 as a factor. And I'm going to write that outside of my integral. So I've now got 1 over the square root of 2 times the integral between u equals 3 over 2 and u equals 0 of 1 over the square root. So that 9 has had a 2 factorised out of it, so that would be 9 over 2. But I'm going to write it like this. I'm going to write it as a number squared, so that will help me with my rule later. So 9 is 3 squared, 2 is root 2 squared. So this is 3 over root 2 squared minus u squared du. And now we're happy to use that rule. It looks exactly like this. A is 3 over root 2, x is u, so we just whack those numbers in to sine minus 1x over a. So now I've integrated and I've got limits. I'm going to put that in square brackets. So sine minus 1 of u divided by a. Divided by 3 over root 2. When we divide by 3 over root 2, it's the same as multiplying by the upside down by the reciprocal. So that would be u root 2 on 3. And that's between u is equal to 3 over 2 and u is equal to 0. We don't have to worry about u equals 0 because that will give us the inverse sine of 0, and the inverse sine of 0 is 0. So we only have to worry about when u is equal... Oh, sugar! I forgot my 1 over root 2 on the outside. 1 over root... It's a really thin 1 over root 2. There you go. So that's 1 over root 2 multiplied by sine minus 1. And we put 3 over 2 in place of the u. Well, the 3's will cancel. That will just give us root 2 over 2. That's a common angle. You might not be used to seeing it like that, but it's the same as 1 over root 2. If you were to multiply the top and bottom by root 2, you'd see that. And sine minus 1 of 1 over root 2, or 45 degrees. I actually still think 45 degrees before I can give you the common angle. Like pi on 3, I think, what's that? That's 60 degrees. What's sine of 60? You know, that's just me, but maybe it's not just me. Maybe other people do that. Who knows? You know, write in answers on a postcard. Sine minus 1 of root 2 on 2 is pi over 4. So the answer is pi over 4 root 2. Done. What was important there? What did we learn? The most important thing was matching our integral to this rule here, because that gave us the substitution u is equal to x minus 1. Yeah, that was the most important thing. And then remembering to factorise out the 2 as well, you had to do that, otherwise you can't just use a rule. Lovely. Okay, so was that redemption for me? I'll leave that for you to decide. I would still like to have an answer to last week's question, just so I can get a little bit of sleep. That might be nice. Yeah, great. Fantastic. All right. Good luck, guys. See you around.